This is Adam Child, and this is my maths project on geometry. We're going to start off with my first topic, angles. We have acute angles, 0 to 89 degrees. We have right angles, which are 90-degree angles. We have obtuse angles, which are range from 91 to 179 degrees. We have straight angles, which are 180 degrees. And we have reflex angles, which are 181 to 359 degrees, because 360 degrees is the full angle. Properties of angles is our next topic. We have the straight line. Two adjacent angles add up to 180 degrees if they're on a straight line. Vertical opposite, angles opposite each other are going to equal each other. We have alternate angles, A equals B, when they're placed in a Z shape along two parallel lines. And the same two lines in an F shape they are corresponding angles, which is A equals B as well. We have interior angles on the same two lines where A plus B equals 180 degrees, and we have supplementary angles which do not need to be adjacent, but otherwise they're the same as the straight line. Next topic is triangles, different triangles. We have equilateral, all sides and angles are equal. We have right angle triangles with 190 degrees angle, and the rest can be anything. We have the isosceles, which have two sides that are the same and two angles that are the same. You have acute triangles where all the angles are less than 90 degrees. You have obtuse triangles where all the angles are larger than 90 degrees, and we have scalene angles where all the scalene triangles where all the angles and sides are different. And some rules for triangles: all three angles will always add up to 180 degrees. A plus B plus C will always equal 180 degrees. And if you add together two angles, you'll get the opposite outside angle. Now, congruent triangles. There's three ways you can identify if triangles are congruent. The first one is side, side, side. Well, where all the sides are equal to each other in the two triangles. So side A is equal to side A on the other one. Side angle side, two sides and the angle that they encompass have to be equal. Or angle side angle, where two angles and the side that they encompass have to be equal on the two triangles. Then we have similar triangles. So in similar triangles, all the angles are equal to each other, but the sides are different. They correspond. 8 corresponds to 6.4, 7 to A, and 6 to B. 8 corresponds to 6.4, so the ratio is 8 to 6.4, so A corresponds with 7, so A is equal to 6.4 over 8 times 7, which is equal to 5.6, and B corresponds with 6, so B equals 6.4 over 8 times 6, which is equal to 4.8. Then we have parallelograms, which always have two parallel sides. AB is always gonna equal CD, or AC will equal BD. Opposite angles are going to equal each other. Angle C and angle B, and angle A and angle D. And angles on the same side are gonna add up to 180 degrees, as angle A and angle C will add up to 180 degrees, as will C and D, D and B, and B and A. And if you cut the parallelogram by one of the diagonals, you're going to get two congruent triangles, triangle ABD and triangle ADC. If you join both diagonals, all the angles made by these diagonals in the middle are always going to be 90 degrees. And the final rule is if one angle in the parallelogram is a 90-degree angle or right angle, all the others are going to be right angles as well, and it's going to be a square. Next is going to be circles. we have radius, which is circumference over 2 pi. So 12 is going to, if the circumference is 12 centimeters, it's going to be 12 over 2 times 3.14, which in the end gives 1.91, which if we take the same thing for diameter, we double it and we get 2.382 centimeters, and that's going to be our diameter because the diameter is 2 times the radius. To get the circumference, we need to take 2 times pi times the radius, which is gonna give us 7.479 centimeters for our circumference of this circle. And other parts of the circle include the chord, which starts and finishes at one point and 2 different points in a circle. We have the second, which passes through the circle, has 2 points of contact on the circle, and we have a tangent which only touches the circle at one point, at the point of tangency. And now a couple of exam questions on geometry. So this is question 7. We just name the absolute and the opposite angles. It's straightforward. They're gonna correspond to each other with the vertical opposite rule. Then part B, we see we have a parallelogram with a 45 and 25 degree angle. We need to find one of the angles. Those are going to be angles that are alternate angles, so one's going to correspond to 45 degrees and the other one's going to correspond to the other 25 degrees, and it helps with it having to measure anything, and it's easier to solve it. And if we take that, we have one angle that's 45, the other 25. If we use the rule in the triangle and we add the angle of 45 degrees and the angle of 25 degrees together, then we're going to get the third angle, which is the outside angle of the triangle, because if you add 2 angles of a triangle, you're going to get the opposite angle, the opposite outside angle on the triangle, and that in this case is going to equal to 70 degrees. On to the next one, question 10. Here we immediately see that the angle K is going to be 110 because it's a vertical opposite angle to the one that's already marked 110 degrees. And if we're going to be looking for angle L, we can see that it's another alternate angle, and that's going to be equal to the 30 degrees of the already marked angle. If we move down to part B, in a rectangle the opposite sides are equal. It can be sometimes true, but as a rectangle it can be different, so they're not always going to be equal, because rectangle only means that it has 4 sides. Now the sum of all the angles in a rectangle is 180. That's always going to be false. Made a mistake there, but it's always going to be false because the 180 degrees is triangles, while the rectangles are always going to be 360 degrees. Whatever you do, it's always going to be 360 degrees. Square has 4 axes of symmetry. That's always going to be true. It has the 2 diagonals, and you can cut it 2 more times. And each angle of a parallelogram is 90 degrees. That sometimes is true if it's a square. Otherwise, it can be something else. And now we're going to move on to the final question. It's a right angle triangle, so we're going to add 90 and 22 together. That's going to give us a total of 112 degrees, which we can then subtract from the 180 degrees that we know a triangle inside angles are when added together. Then we're going to get 68 degrees as our answer, and that's going to be angle P, and that's going to be our answer for this question. We're going to skip B because on a computer it's impossible to draw nicely, without a pen. But on the bottom it's going to be hypotenuse. We're looking for hypotenuse. We're going to use the theorem of Pythagoras. A squared plus b squared equals to c squared, which is going to mean that we're going to have 5 squared and 12 squared will add up to c squared. Yeah. And then if we calculate, that wasn't an eraser. Then if we calculate that, we're gonna get 5 squared is going to be 25, and 12 squared is going to be 144. And add those two together, you're going to get 169, and that's going to be equal to c squared, not c yet, because to get c, we're going to need to get the square root of 169. If we take that, that's going to give us 13. So our answer is going to be side C. The hypotenuse is going to be 13 meters long. And that's going to be everything for now and for this project. So thank you very much for watching, and goodbye.